For the rest of this module, you'll be working with DigitalOcean to create and configure online cloud resources. I chose DigitalOcean primarily because of its ease of use compared to other products such as AWS, as well as its continuing popularity and great user documentation. DigitalOcean was first founded in 2011 by Ben and Moisey Uretsky. They felt that most hosting companies of the time were targeting large enterprises, leaving many smaller software developers and startups behind. DigitalOcean was one of the first hosting providers to offer virtual machines exclusively on solid-state storage, giving them a performance edge over many of their peers, while often being cheaper overall. Currently, they are the third largest hosting provider in the world, with 12 worldwide data centers serving over 1 million customers. In this video, we'll discuss the first steps for getting your first cloud server, referred to as a droplet, on DigitalOcean, configured and secured. Let's get to it. First, if you haven't signed up for the GitHub Education Student Developer Pack, I highly encourage you to do so. Among many other perks included in the pack is a $50 credit for new users on DigitalOcean. So, if you haven't used DigitalOcean before, or would like to create a new account for this class, you should take advantage of that resource. In total, the entire class should use less than half of that credit as long as you don't get behind, so you'll have plenty left over for other projects. Finally, if you have a friend or colleague already using DigitalOcean, you can contact them for their referral URL before you sign up to do them a solid favor, netting you a $10 credit, and they get a $25 credit once you spend $25 at DigitalOcean. It's a win-win for everyone involved. Once you are logged in, you'll be ready to create your first droplet. I'm going to walk you through the steps here and talk through some of the options available, just so you'll know what's available here. To create a droplet in DigitalOcean, click the Create button up here in the upper right, and then select Droplets. First, you'll be prompted to select an image. DigitalOcean offers many different types of images, including Linux distributions, containers, and one-click applications. The last two options are really handy if you need just a particular service or type of machine, but in our case, we'll select the Ubuntu distribution. Currently, DigitalOcean offers all LTS versions of Ubuntu that are still supported. We'll choose the Ubuntu 18.04 x64 option. Next, you'll need to select a droplet size. Droplets on DigitalOcean are sized by the amount of memory they offer, as well as the number of virtual CPUs available and the size of the storage disk. There are many different options to fit a variety of needs. For this class, we'll select the cheapest option, which has 1 GB of memory, 1 virtual CPU, and 25 GB of storage space. It is more than enough for our needs and only costs $5 a month. DigitalOcean also provides the option to have automatically created backups of your droplets for just an additional fee. I won't enable that option, but you're welcome to do so if you'd like to have that feature available. Similarly, they also offer the ability to have your storage volume separate from your droplets. This is handy if you'll be building or rebuilding your droplets and want to make sure the stored data is unaffected. We won't be using this option for this course. Below that, you'll be able to choose your data center region. In general, it is best to select a region close to you and where you'll be accessing these droplets. So, I'd recommend selecting one of the New York or San Francisco options. If you are creating multiple droplets, as you will for this class, make sure they are in the same data center region so they are able to communicate with one another internally. There are a few other options that you can enable. The first is private networking, which allows droplets in the same data center region to communicate on a private network that is internal to DigitalOcean's data center. This is great if you'll be storing data on one droplet and accessing it via another, as you can use the private network to protect that connection from eavesdropping. Next, you can enable IPv6 access to your droplet. Depending on your network infrastructure, you may or may not find this useful. We won't be enabling it in this course. The User Data option allows you to provide some initial configuration information to your droplet using the Cloud Init program. If you are creating many droplets from scratch that all need the same configuration, this can be a very powerful tool. However, for this course we'll be performing our configuration manually, so we won't be using this right now. Finally, DigitalOcean offers advanced droplet monitoring at no extra charge. Let's enable that option here, and later we'll look at the information it collects for us. You can also add SSH keys directly to your droplet. If you do so, the system will be configured to prevent SSH login via password, and you won't receive the root password via email from DigitalOcean. If you have already configured an SSH key with DigitalOcean, you can add it to your droplet here, but if not, I'll walk you through the steps to do that later in this video. Lastly, you can create multiple droplets with the same settings. For this lab, you'll need to create 2 droplets named front end and back end. For this example, however, I'm going to create just one droplet and name it example. As part of this lab, you'll have to extrapolate what I demonstrate here on a single droplet to your setup with multiple droplets. Finally, I can click the Create button to create my droplet. After a few seconds, you should see the IP address of your droplet in your dashboard. Let's click on it when it appears, and we'll see some additional information about our droplet. At the top of this page, you'll see your droplet's public IP address as well as the private IP address for the internal network. Notice that the private IP address begins with a 10, which is one of the reserved network segments we discussed in Module 3. On the left of the page, you'll see several options you can explore. For example, clicking the Access option will allow you to launch a virtual console to connect to your server. This is very handy if you accidentally lock yourself out of the droplet via SSH. Of course, you'll need to actually know a password for an account on that system to log in via the console. Thankfully, if you forgot your root password, there is a button below to reset that password and have it emailed to you. For this example, however, let's use SSH to connect to our droplet. I'm going to use one of my Ubuntu VMs from the earlier labs for this process, but you are welcome to use tools from your own host machine instead of running it in a VM. Mac and Linux users have easy access to SSH via the terminal already. For Windows users, I recommend using the Windows subsystem for Linux to get access to SSH through Ubuntu installed directly on Windows. See the video on WSL in the Extras module for more information on installing and configuring that application. To connect, you'll use a command similar to this one. SSH root followed by the @ symbol and then the IP address of my system. As before, I'll have to type yes to accept the key fingerprint for the server. When prompted, I can enter the password I received via email to log into this server. When you first log in, it will prompt you to change your password. If everything works correctly, you should now be logged in as the root user of your droplet. Of course, if you've been paying attention to this class, you should know that it is a very bad idea to use the root account directly on a system. That goes double for when you're working in the cloud. So, the first thing we should do is create a new user named CIS 527. As you'll recall from Module 1, you can do so using the add user command. It will ask you a few simple questions about that user, and then create that user for you. You'll also need to give that user administrative privileges. You can do so using the usermod command. We'll do usermod-a to add, -g for a new secondary group. Then I'm going to give it the group name sudo, and finally the username CIS 527. Once that is done, we should log out of the root account and log in as the new account. So let's exit for now. Back on our local machine, we'll want to set up some SSH keys so we can log in securely. If you'd like to learn more about this process, please review the SSH video in the Extras module. First, if you haven't already, you'll need to generate a set of SSH keys on this system. We'll use SSH keygen. We'll specify the type of key as RSA and the number of bytes in the key as 4096. I'll accept all the defaults, and there we go. Then, once the key is created, you can copy it to your DigitalOcean droplet using a command similar to this. I'm going to do SSH copy ID, then I'm going to give it the username, the @ symbol, and then I need the IP address of my droplet. Here it will ask me for the password, and if I did it correctly, it should add that key to the system. Now we can check to see if it worked by logging in via SSH. If everything works correctly, you should not be asked for your password at all unless you put a passphrase on your SSH key. Of course, at this point you could also create an SSH config file to make this process even easier. The SSH video in the Extras module has details for how to go about doing that. Once you've created your new user and switched to that account, there are a few important security steps you should take to make sure your droplet is properly secured. First, you should configure the firewall to only allow the ports you intend to use on this system. For example, you might allow port 80 for HTTP traffic, port 443 for HTTPS traffic, and port 22 for SSH traffic. In addition, you could restrict the IP addresses that are able to access certain ports. For this example droplet, I'm going to enable those 3 ports. To enable a port, I will do sudo ufw allow followed by the port I would like to allow. Once that is done, I can enable the firewall, and then I can check the status. For the lab assignment, your firewall configuration will be a bit more complex, so make sure you read the assignment carefully before enabling the firewall. If you end up locking yourself out of the system, remember that you can use the console through the DigitalOcean website to get in and fix problems with your firewall configuration. In addition, I recommend securing your SSH server by disabling password authentication and root login. You can do so by editing the SSH configuration file. To edit that file, you can do sudo nano and then the path /etc/ssh and then it's sshd config as the name of the file. SSH servers on the internet receive sometimes hundreds or even thousands of login attempts per day from hackers trying to exploit systems with weak passwords. If your system doesn't even accept passwords, it is just one less way they can potentially get in. You can also change the port that the SSH server is listening on. This is a little bit of security by obscurity, which isn't really security by itself, but it can definitely help cut down on those malicious login attempts. The lab assignment directs you to do just this. Of course, make sure you update your firewall configuration accordingly when you've made this change. Once you've made your changes, you can restart the SSH server using sudo systemctl restart and then the name of the SSH service. Lastly, you may want to perform steps such as updating the time zone of your server and configuring the Network Time Protocol or NTP client to make sure that the system's time is synchronized properly. One other step you may come across in many guides is enabling swap. Swap in Linux allows you to effectively use more RAM than what is available on your system. This is especially handy if you are dealing with large datasets that won't fit in RAM. The desktop version of Ubuntu automatically does this for you, but many cloud providers such as DigitalOcean disable this feature. Since they are in the business of providing cloud resources, in general they will just want you to scale your resources accordingly to have enough RAM available instead of using swap. In addition, using swap on a solid-state drive can degrade performance and shorten the life of the drive. So I don't recommend enabling swap on your DigitalOcean droplets at all, unless you find a particular use case that would make it worthwhile. With that information, you should be ready to configure and secure your first cloud server. Next, we'll look at how to access a cloud resource using a domain name and configure that resource accordingly.